So in this assignment 2, we will be implementing assignment 1 in Arduino framework. For that, we will first log in into Ubuntu using root this2 command. Now we are into the Ubuntu system. I will cd into my FPGA lab folder. So here we can observe that I have already did my assignment 1. What I will do is I will download the template which is shared by sir, that is platform IO template for Arduino Uno. For that we will be using svn command and typing the GitHub address of that particular template. So here we go. And all the files from that template are now in our FPGA lab folder. Here we can observe the hello folder which contains all the file. I will rename this hello folder as assignment 1. For that we will use the move command, move hello, and rename it as assignment 2. Yeah, so if we list it again, now it has become assignment 2 and I will cd into assignment 2. And if I list it, we can observe that all the files are already there. Here we will modify our main.cpp file using the Neo Vim editor. So I will cd into the source file and use nvim command to open the main file in Neo Vim editor. So we already have a program here. We will modify this program as per our assignment 1 to implement it on Arduino. So I will delete the previously written lines so that we can write our new code. So the command is double D, quickly press it to delete. Now I will be going into the insert mode and writing my particular program. So I will first define all the pins which I will be using for my program. So I have 3 inputs, so I will define them. The input A is defined as pin 2. Input B is defined as pin 3. While input C is defined as the pin 4 of Arduino. Now we will have the output pins also. So I will define the output using NAND logic at NAND output variable, which is at pin 12. I've taken this pin. I've connected an external LED to this pin to see my output. And also we have inbuilt LED for verifying the KMap expression, which is already declared inside the Arduino.h file. Now I will declare my variables. So these are my variables to store the data from GPIO pins. So I will take 3 variables like integer A, B, and C for taking the inputs from GPIO pins 2, 3, and 4. And then I will be taking a variable called KMap output to evaluate the output using the KMap expression. And then I will take an extra variable NAND output to evaluate the output using NAND only gates. There is one intermediate variable I will need which is temporary for evaluation. I will also need a function of NAND gate, so I will implement it above the setup and the loop. So this is a function for 2 input NAND gate. So it returns an integer value and the function name is NAND. It takes 2 integer value I1 and I2, and the body returns NAND implementation, that is AND between I1 and I2 and then taking the complement of AND. So this is what this function will return. I will now close this function. Now I will in setup loop I will set up my GPIO pins which will be used for this particular assignment. So I will be using pin mode function for that. As I said, there is already a variable defined LED built in for at the 13th pin. So this is for built-in LED. I'm defining this pin as output pin so that we can observe the output at the built-in LED. This output shows the K-map expression. Now I will define another output pin, which is our NAND output as defined in the above code. Similarly, I will define the input pins ABC. So these were my declarations for pins in the setup loop. Now in the main loop, I will be taking inputs from 3 GPIO pins, that is 2, 4 and 3, which are for A, B and C respectively. So to read the input from these pins, I will have to use function called as digital read. So digital read reads the status of a GPIO pin. So we will read from GPIO pin A and store it in our A variable. Similarly for B and C. So I've read my input. Now I will implement the K-map logic, which I obtained in the first assignment. I will implement the same K-map expression. So I will use the input which I read at the GPIO pins. So this is the K-map expression. Now the expression which is using NAND gate only, I will also evaluate that. So first I will have a temporary variable to evaluate one part of the expression and then use the temporary variable to evaluate the overall expression. So temporary variable is just the intermediate variable. It is nothing more or less. So this expression is the same as what I implemented in the first assignment. I have given the PDF link on the GitHub. The same thing I am referring to write this expression. Now the final NAND output, I will use the intermediate temporary variable. The temporary variable was just to reduce the work because it has been used 2 times here. I cannot write the entire expression 2 times, therefore I used it. Just to check everything is fine. Here it is. So I have both the expression now. So I have to change the output, that is the LED, which is connected at the inbuilt LED pin 13, and one LED is defined by myself, which is at pin 12. So I will write if K-map output is equal to 1, then I will turn on the LED, which is the inbuilt LED at pin 13. So I will again write using the variable LED built in. Else if K-map output is 0, then I have to turn off the LED. So I will write the same function and I will turn off the LED. Similar thing will happen on the NAND output. So very similar what we have done in the previous 4 lines. And if the NAND output is 0, we will have 0 at, sorry, this is not the inbuilt LED. We have to remember this is the NAND LED which we should use. So I will change this variable to NAND output. And again, NAND output is nothing but a variable which contains 12 as our pin number. So this is it. This is the program which I have written to verify the output on Arduino. So I will just give inputs ground or 5 volt at these ABC pins, and I'm observing two different LEDs, and those two LEDs should match with each other. So one LED represents the NAND output and one LED represents the KMAP output. So just checking the program once. Sorry, here output should be capital. So everything looks fine. So to come out of the insert mode, I have to press escape, and then I have to give command WQ to save and exit. And if I give the command again nvmin main.cpp, I could see whatever I have written is saved. So this is how we can use NeoVim editor to write programs. Now I will compile this program using platform IO. So I will just exit this again without saving. So after checking the program once again, I found few mistakes, so I will correct those. In my programs, like there were mistakes in variable names, which I have corrected now. So now the program seems okay, and hopefully it will compile. So I will escape, save and exit using WQ command. Go back a step and run PIO run command to compile my main.cpp file. So this time my firmware.hex file is generated, and now I can send this file to my Linux PC using SCP command over SSH protocol. So for that I will write scp.pio.build, then I have uno firmware.hex. This is the file I want to send, and I want to send it to my PC, which is Sachin, and at the rate the IP address of that PC. So I've already found the IP address on my Linux PC, which is this one. Send this to my documents folder in my PC, and that hex file will be sent to this particular path. So this is scp command. It will ask for the password of the PC, so I will give my password, and it says yes, the firmware.hex file is transferred. Now I will use my Linux PC to flash this file on my Arduino hardware. So currently we have a Blink program inside the Arduino, but we want to replace that Blink program to our logic which we have written. So you can observe I will use avr-dude command. Here we can observe I have given the chip, the microcontroller which is used by Arduino Uno, and I have defined the programmer which is Arduino. I have defined my port which is ACM0, and then the baud rate 11,000 1,15,200, and then I have given the path of my hex file which I want to flash. So here after giving this command, I have connected my Arduino board to my PC using a USB cable. Let me disconnect and connect it again. So here we can observe it has successfully written that command. I have opened the truth table which I have implemented. So I will take few cases and check it on my Arduino hardware. So I will keep this 0 case wherein AB are 0 and C is 1. We should get 0 output. Both the LEDs should be off. And then a 1 case I will take wherein A is 1, other two are 0, and we will get 1 output. So these two cases I will check. I have taken these two cases randomly. We can check for other cases as well. So this is my hardware connection. Here we can observe 2, 3 and 4 are the GPIO inputs which I am giving by connecting them to ground or VCC. Ground and VCC terminals are available at the other side of the Arduino as pointed. And here we have external LED connected to pin 12 and internal LED, which is this one, connected to pin 13. So external LED represent the NAND output expression, while the internal inbuilt LED represent the minimized KMAP expression. So as per the truth table, we have taken the first output, which is 001, and we can see A and B are connected to ground and C is connected to VCC, which means 001 is the input, and here we can observe the output is 0, both for the external LED and the internal LED. Now I have changed the inputs. So now A is connected to the orange wire. A is connected to 5 volt, which is 1, and B and C are connected to ground, which is 0. So we are giving 1 0 0 as the input, and as per the truth table we are getting 1 as the output. So for NAND output we are getting 1, as well as for KMAP minimized expression we are getting 1, the inbuilt LED. So this verifies the truth table and the output obtained in the assignment 1. Thank you very much.